In this video, we will investigate the types of symbiotic relationships that exist between microorganisms and their host. We will start by defining types of symbiosis, and we will then follow with a discussion of the normal microbiota and how the normal microbiota can become opportunistic pathogens. We briefly explored associations that exist between microorganisms in Chapter 6. Here we are assessing the relationships that exist between microorganisms and their host. The relationships that exist between the microorganism and their host are symbiotic relationships. The term symbiosis means to live together. Symbiotic relationships are those that exist between two organisms in which one is dependent on the other. There are three types of symbiotic relationships that can be formed between a microorganism and their host: mutualism, commensalism, and parasitism. Mutualism is a type of symbiosis in which both organisms benefit from the relationship. The image at the bottom shows a type of termite that requires a mutualistic relationship with a protozoan and bacteria that reside within its gut. The termite is unable to digest cellulose found in the wood because they lack the necessary enzymes. Bacteria residing on the protozoan provide the protozoan with the necessary enzymes to break down cellulose. As the nutrients are released, the termite has access to them. In return for the nutrients, the termite provides the protozoan and bacteria with a home that is warm and moist. The termite would die without this relationship. Humans also have mutualistic relationships with gut bacteria. We provide the gut bacteria a warm, moist, nutrient-rich environment in which to live. In return, the bacteria produce nutrients such as vitamins that we cannot produce and make them accessible to be absorbed across the intestinal lining. This relationship, however, is not required like the relationship between the termite and its gut microorganisms. The microorganisms of our gut can reside elsewhere in the environment, and we could get the nutrients provided by the bacteria from our diet. Another type of symbiosis, known as commensalism, is a relationship in which one organism is benefited while the other neither benefits nor is harmed. Your textbook provides the example of Staphylococcus colonizing the skin. Typically, Staphylococcus resides on the human skin without causing any harm to the individual. The Staphylococcus benefits by having a home in which to reside that provides nutrients to the bacteria. The human, however, does not seem to benefit and is generally not harmed. It is more difficult to classify a relationship as commensalism because the individual may be benefiting in such a manner that it is not readily discernible. For example, we will learn that our normal flora, those microorganisms that normally reside on the human body, can outcompete other organisms. In some cases, those organisms might have been pathogens, thereby protecting the host. It may be that an organism like Staphylococcus residing on the skin is preventing a potential pathogen from taking up residence. A third type of symbiosis is parasitism. Parasitic relationships are those in which one organism is benefited and the other is harmed. This is the case with pathogenic organisms. Remember from Unit 1 that a pathogen is an organism that causes disease in its host. The pathogen benefits from nutrition it acquires from the host, while the host tissues are damaged. The level of damage sustained by the host varies depending on the pathogen. In some cases, the damage is only slight. In extreme cases of parasitism, the parasite will kill its host. Killing the host is not an ideal situation because a good parasite, as we will see at the end of this chapter, must move on to another host. Many parts of the human body are free of any microbes. Regions that are typically free of microorganisms are known as actinic environments. The internal organs, tissues, and fluids of the body are generally actinic. There are also a number of regions of the body that are rich in microorganisms, such as the skin, respiratory tract, and gastrointestinal tract. The microorganisms that can take up residence on the human body live in mutualistic or commensalistic relationships with the human. The organisms that reside on surfaces of the human body without causing disease are known as the normal flora. Other terms you might encounter that are used to refer to the normal flora are microbiota and indigenous flora. The normal biota are classified into two groups. Those known as resident microbiota are organisms that establish residence with the individual throughout their life. These organisms are found residing on the skin and all of the mucous membranes. Another group, known as transient microbiota, are organisms that come into contact with the body but for some reason are unable to colonize the individual. Often these organisms are unable to establish residence because they are outcompeted by flora that are already present. They may be eliminated by the host immune system, or they are removed because of chemical or physical changes on the body. While in the womb, the fetus is normally protected from microorganisms. Humans begin to be exposed to microorganisms and gain their normal flora as soon as the fetal membranes rupture. As the baby passes through the birth canal, they are exposed to microorganisms. Healthcare workers and family members help in the colonization process as the baby is handled. The baby's first breath and subsequent breathing of air aids in colonizing the respiratory tract. As the baby begins to feed, the gastrointestinal tract becomes colonized. The bacteria that reside within the gastrointestinal tract of bottle-fed babies differs from those of breastfed babies. Those who are bottle-fed contain a mixture of coliforms, lactobacilli, enteric streptococci, and staphylococci similar to the adult intestinal tract. Breastfed babies, on the other hand, contain intestinal flora dominated by bifidobacterium, which is favored because of a growth factor found in the mother's milk. Within the first few months of life, most of the microorganisms that form the normal flora are established. The composition of the flora may differ with the region of the body or at different times during the life of the individual. Our normal microbiota live in relationships such that they do not cause diseases under normal circumstances. On occasion, some of our normal flora can cause infection and disease if the opportunity is provided. Such organisms are referred to as opportunistic pathogens. Let's think about the conditions that would permit a microorganism the ability to become an opportunistic pathogen. Our normal microbiota exist in specific regions of the body. If they are introduced to regions of the body where they would not normally reside, or to regions that should be axenic, there is the potential for them to cause infection and disease in those regions. For example, E. coli is a normal component of the microbiota of the intestines. However, if E. coli is found in the urinary tract, it can cause urinary tract infections. Staphylococcus are another microorganism that normally resides on the human body. They are commonly found on the skin of humans. However, if the Staphylococcus makes its way into the regions that should be axenic, it may lead to infections. Another manner in which the microorganism may become an opportunistic pathogen is if the host immune system becomes suppressed. A variety of things can suppress an individual's immune system, including physical and emotional stress, immunosuppressing drugs or chemotherapy, existing infections, among many other things. HIV infections are a prime example of how a suppressed immune system can permit opportunistic pathogens to cause infection and disease. Human immunodeficiency virus is a virus that targets the immune system, suppressing its ability to protect the individual. Human immunodeficiency virus targets a cell known as the T helper cell. The T helper cell functions to activate both the cell-mediated and antibody-mediated lines of adaptive immunity. As the infection spreads, the number of T helper cells are reduced. The patient becomes susceptible to infection and disease caused by opportunistic pathogens that would not be able to cause infection and disease in an individual with a healthy functioning immune system. Finally, changes in the normal microbiota of an individual can provide the necessary conditions for an opportunistic pathogen to cause infection and disease. Under normal conditions, our flora compete with one another to occupy the regions of the body in which they reside. If the balance of those organisms are disrupted, the opportunistic pathogens may be provided an opportunity to flourish and ultimately cause disease. An example are yeast infections in females following a course of antibiotics. When the female is prescribed a broad spectrum antibiotic, meaning an antibiotic that kills a wide range of bacteria, the antibiotic not only kills the microorganism causing infection, but also effectively targets the bacteria of the normal flora, thereby killing them. Under normal conditions, the reproductive tract has bacteria known as lactobacilli that grow and create an environment unfavorable for the growth of yeast. However, upon taking a course of broad-spectrum antibiotics, the lactobacilli are killed off, and the yeast has the opportunity to flourish in the reproductive tract and thus cause infection.